numerical dude here, and today we're going to be talking about exponents. I wanted to show you a little bit about an exponent. You have two numbers here. One of them is the exponent. Can you guess which one? Well, it's the little number. That's it. That's all the exponent is. Now what does it mean? It means you take this big number, which they call the base, and you multiply it by itself the number of times you have there. So I would take the 5, write it twice, and then multiply those two numbers. That's all the exponent is. If I took it to the third power, you would do it 3 times. Okay? That's it. That's all the exponent is. Now let's see where it came from. Well, in algebra, let's just look at it this way. If I was using algebra and I did x plus x plus x, everybody knows what that is, right? It's 3x. Nice and simple. But now if I wanted x times x times x, well, now I got these 3, but where am I putting the 3? I can't put it in front. Front's already taken. I can't put it in the back because this is the same thing as this. I can put it here, I can put it here, and here. Those are your 4 options. Only one of them is agreed on by mathematicians everywhere. So you have to use the same notation. And the one that's agreed on is right there. So that's it. X cubed. So you put it in the top right corner. That's where you put the exponent. I think it was done first time by a French mathematician. I don't recall the name. I'm sorry right now. It's in the 1500s or 1400s, around then. All right. A few properties I just want to show you. When you're adding, the bases have to be the same. So if you have an x squared and an x squared, that is 2x squared. Okay, some people put x to the 4th. It is not. You have 1x squared over here and 1x squared over there. Together you have 2x squared. If you need a visualization, the area of this is x squared. That's why they call it a square. I add another one. Area of this is x squared. So if I have 1x squared here and another x squared, then I have 2 of them. That's why you have 2. Same as x cubed. If I have an x cubed and an x cubed, well, what is an x cubed? Now it's 3 dimensions. And here's an x cubed also. And they're all x by x by x. So if I'm adding this box with this box and they're the exact same size, because their bases are the same, then I have 2 of them. That's it. And if I were to add an x cubed, if I add an x cubed with an x squared, well, guess what? If you take an x cubed and an x squared, 1 and 1, well, you think you're going to get a box and if it was a box and a sheet of paper, you think together they're going to be 2 boxes, sheets of paper? No, it'll always be a box and a sheet of paper. Therefore, this is just that. Okay? You can't combine it. That's it. And there's one other thing I want to show you. It's raising the power to a power. Like this. Whoops. Let's make that a 2. X to the 3rd squared. Well, this means you have an x to the 3rd times x to the 3rd. In my other video, I explained how these are. You also have to look up exponents. What you do here is you add them. So the quickest way to raise the power to a power is just by multiplication. So x to the a to the b power is the same as x to the ab. It's a little out of order. I should have done this to end the other video. Well, that's all I wanted to say about this. And then the other video on exponents will show you some more things. This has been Radical Dude, and I hope I was able to teach you something. Thank you.